we've got about 5 more minutes, so 5 more minutes. And maybe time for 1 or 2 more questions.
Yeah, so try not to be on the fence here. Are you for or against string theory?
String theory. Well, you know, I was all for it back when they started that adventure back in early 80s, in 1982. And in fact, at the time I was at the University of Texas, where some of the leading thinkers at the time were based. And string theory is like the theory of everything. It would get you an understanding where Einstein's theories end and pick up it would allow you to divide by 0 legally, okay? That's what string theory would allow you to do. It'll allow you to describe the universe at the moment of the Big Bang, which is where right now our theories can't get us there, possibly even before the Big Bang. It would unify the science of the large, general relativity, with the science of the small, quantum mechanics. All right, if that's the case, fine. I asked him, how close are you? He said, a couple of years away, we're almost there. So 1985 rolls by. Oh, how's it going? We're going well. How close? Oh, a couple of years away. And they've been saying a couple of years for 27 years, 26 years. So I'm kind of losing enthusiasm. But they're the only game in town. And they're really cheap to fund. Like a pencil, a pad, throw in a laptop. They're good. You send them off to their office, let them do their thing. I don't have a problem with that, because they're the only game in town. I'm not going to stop them. But I'm losing my enthusiasm. And you ask them, they say, it's a very hard problem. Now, again, the book was titled Optical Illusions, Not Brain Failures. So a string theorist will not say, we're all just too stupid to figure this problem out. But maybe we as a species are too stupid to figure it out.
Keep the faith.
If it's cheap, I will. Yes, I'm not going to start directing funds from other research that might have a shorter time horizon for the discovery of what they're after. I'm yanking it like that. But like I said, they're inexpensive, and there aren't many of them, and they're harmless. Yeah, the question, yes. Well, those are like the particle physicists. You know, you always got to give the particle physicists their next accelerator. And they're driven by more than just whether they find the string theory particles. But yeah, sir. Mm-hmm.
I'd like to ask you kind of a hypothetical. If black holes...
Oh, like falling into a black hole was not hypothetical? Are you the only hypothetical? Like meaning aliens was not hypothetical? Sir, you're not the only hypothetical question this evening, okay?
Well, I just thought I'd preface it that way.
Okay.
If black holes didn't exist, would the universe as we know it exist? And if that's the case, is that just another example of a finely tuned universe?
The black holes, as far as we know, don't play any fundamental role in the universe. Most of the universe goes on just fine without ever looking at, thinking about, smelling a black hole. So what black holes do is enable us to explain a lot of what would otherwise go unexplained, like the engines that drive what we call active galaxies. These are galaxies that are the engines of quasars, for example. We have no accounting for those but for black holes. The behavior of stars in the centers of galaxies. We need black holes to account for those. But if you took away all those black holes, it's not obvious the universe would care at all. It would still could happen just the way it did. So they're rare enough so that it's hard to think of them as fundamental.
Except that maybe that's where the dark matter...
Can you get closer to the microphone?
Oh, except that maybe that's where the dark matter is?
Oh, well, yeah, because black holes are dark and things. However, we've already counted for all the black holes in the ordinary matter part. And then, because black holes are ordinary, they do things to light, and dark matter does not interact with matter or energy or light or anything that is in our universe in any way at all. It's as though we're not even there. It's quite embarrassing, actually, but we're completely ignored by it.
So in no way could, say, like nano black holes or micro black holes account for the missing matter?
The nano black holes would evaporate very quickly. And we would see them explode. We would see sort of bursts of those around the universe, and we don't see that. So nano would be small. That's how you're using that adjective. So, no, you can't hide it in ordinary matter. Dark matter is a completely different species of object. We've accounted for all the ordinary matter that there is.
I'm sorry, we're with this one right here, and then we're out, I'm afraid.
Given the
Sorry.
curvature of space-time, what is the shape of the universe? If space and time are curved, what is the topology in the shape of the universe?
Well, the universe, given the distribution of matter, which is it's statistically uniform, so the observable universe is a sphere. You look in every direction, you hit our horizon at about 14 billion light years out. And that's artificial in the sense that when you're a ship at sea and you look out to your horizon, you're not saying that's the whole ocean right there. No, that's the ocean that you can see. If you move to another spot, more ocean comes into view. If we were in another part of the universe, we'd see a horizon corresponding to that spot rather than to ours. So in that simple sense, we are spherical. Our rate of expansion, however, is such that if you want to think of the geometry of the curvature, we're in a one-way trip expanding that'll never come back, and that is what we call negatively curved universe. And a negatively curved space is what we call a saddle shape. And when you negatively curve, there's no coming back on itself. So that's our shape.
I think we're going to have to go on to your closing little puzzle. I
This
appreciate
liquid has
everybody.
like a thing.
You got-
I'm a second grade teacher, that's why I'm being so pushy. I'm supposed to hand
You're a
deliver.
second grade teacher, that's cool. Teachers are like the heroes of the world.
I promised I would bring them.
Okay.
They worked really hard on these letters and I just wanted to deliver them.
These are letters to me? Oh, that's sweet.
They came
Bring
up,
it-
they
bring
only
it.
had,
Thank you.
they only had one.
Okay. Okay. So that's the science lecture version of tossing flowers on the stage. Is that right? Is that what that is?
They were,
Letters from second. I'm deeply touched.
they were upset that you were getting such negative letters, and so they wanted to write you letters from other scientists. And to come up with a question from 27-year-olds was hard. They just wanted to know, what are you most passionate about in your job?
What in my job am I most passionate about?
Yes, and I know we're in a hurry, but if I didn't deliver those, I would be dead.
Okay, thank you. Most passionate. Well, I have several passions in life, but I would say one of them is, on the public side, is trying to raise the level of science literacy a few notches in the electorate. I think that's fundamental to the future of the nation. And
Can we also have a hand for our panel? You got one
can
more
I
thing.
leave you that,
You may.
that disturbing thought that will keep everyone awake at night?
Please do.
May I? Okay. You sure? I'm not accountable if you can't get to sleep tonight. Okay? It's what? Oh, so move back. Okay, yeah. Thank you. We could come back here. So. There. Okay.
I'm safer back here.
No. Okay. All right. So I can see everybody. We got everybody. You guys over here. You're good troopers. Looking at the back of his head here, right? Yeah. Okay. Good. All right. Just a couple of thoughts. One that's sort of deeply cosmic, and another one that is fascinatingly disturbing, I think. But you'll be the judge of this. Consider a couple of fundamental facts that has been gleaned in the past 60 years. That the ingredients, if you had asked your chemistry teacher 50 years ago, once you looked at that mysterious chart of boxes that sat in front of your class, the periodic table of elements, where did those elements come from? The chemistry teacher would actually not have an answer for you. They'll say, well, we dig them out of the earth. That's not where they come from. It took modern astrophysics to determine the origin of the chemical elements. We observe stars. We know what goes on in their center. They explode, laying bare their contents. And what we have discovered is that the elements of the periodic table, that which we are made of, derive from the actions of stars that have manufactured the elements, exploded, scattered their enriched guts across the galaxy, contaminating or enriching gas clouds that then form a next generation of stars populated by planets and possibly life. And so when you look at the ingredients of the universe, the number one ingredient is hydrogen. Next is helium. Next is hydrogen, helium, oxygen, carbon, nitrogen. Those are the top ingredients in the universe. Now you say, well, okay, that's kind of cool. Well, and you look at Earth, because we like thinking of ourselves as special, we say, oh, we're special. Well, what are we made of? Well, what's the number one sort of molecule in the body? It's water. It's water. Well, what's water made of? H2O, hydrogen and oxygen. Hydrogen and oxygen. In fact, if you rank the elements in the human body, with the exception of helium, which is chemically inert, useless to you for any reason other than just to inhale it and sound like Mickey Mouse, you can't die from helium unless that's all you breathe. Number one in the human body is hydrogen. Matches the universe. Number two is oxygen. Matches the universe. Number three, carbon. Matches the universe. Number four, nitrogen. Matches the universe. And for each of us, the fifth element, other, is the same in both places. Okay? Other. So, we learned in the last 50 years that, of course, not only do we exist in this universe, it is the universe itself that exists within us. And had we been made of some rare isotope of bismuth, you would have arguments, hey, we're something special. But there are people who are upset by that fact, saying, well, that mean we're not special? Well, I think it's special in another kind of way. Because when you look up at the night sky, it's no longer we're here and that's there. It's that we are part of that. And that association, for me, is actually quite enlightening and ennobling and enriching. In fact, it's almost spiritual, looking up at the night sky and finding a sense of belonging, given what we've learned about the night sky. And so now we have ourselves. Now, are we alone in the universe? We're made of the most common ingredients there are. And our chemistry is based on carbon. Carbon is the most chemically active ingredient in the entire periodic table. If you were to find a chemistry on which to base something really complex called life, you would base it on carbon. Carbon is like the fourth most abundant ingredient in the universe. Isn't that rare? You can make more molecules out of carbon than you can all other kinds of molecules combined. So if we ask ourselves, are we alone in the universe? It would be, in spite of my diatribe about UFOs, I tell you in the same breath that it would be inexcusably egocentric to suggest that we are alone in the cosmos.